Alright, welcome to chapter 3. We're on page 146 in your book. We're talking about lines and angles in this chapter. Parallel lines having equal slopes. This is our notation for parallel. And again, the definition of parallel is that the lines have equal slopes. Parallel planes look like this. Perpendicular lines. The definition and notation, here's our new notation. Here's an example of opposite reciprocals. This is a positive slope. Let's say that this would have a slope of 2/7, and our lowercase m is an abbreviation for slope. This slope, if perpendicular, will be the opposite reciprocal. So this slope would be -7/2. Skew lines are non-intersecting, non-coplanar. The two that we really need. Alright, these vocabulary terms are on page 147. What happens when we introduce a new line called a transversal? And the transversal here is red. The transversal intersects two other lines. Keep in mind that we do not have parallel lines at the moment. Any two lines that are intersected by a transversal will generate a bunch of new angle pairs. Before we get to the angle pairs, let's first talk about interior region and exterior region. This aqua blue region is between the two given lines. This is our interior. And these two yellow regions are both exterior regions. Corresponding angles. The same location at a different intersection. This angle, which I'll call angle 1, and this angle, for now I'll call that angle 2, these have the same location at a different intersection. These would be an example of corresponding. This angle right here, which I'll call angle 8, and this angle right here, notice that I'm not marking them congruent because these are not parallel, but still this location, angle 8 and angle 9, would also be corresponding. Alternate interior angles. Let's call this angle angle 7, and let's call this angle, which has a different mark, because these are not parallel, we do not know any relation between their measures, so they get different measurement marks. And let's call this one angle 10. These are on the other side of the transversal, or on opposite sides of the transversal, and they're both on the interior. So these are what we call alternate interior angles. This pair would also be alternate interior angles. Alternate exterior, same idea. We're going to be on different sides or opposite sides of the transversal. And if I'm starting with this angle right here, this location would be the pair that we call alternate exterior angles. And our last new pair of angles are called same side interior. Interior indicates we are in this region between the two lines. And if we're on same side, we're saying that this angle and this angle would be described with this new relationship. Same side interior. This angle and this angle would also be considered same side interior. For this last page, we are talking about parallel lines. And because we have parallel lines given, and parallel lines have equal slopes, this is our notation for parallel lines on a construction or in a sketch. Again, we need to understand this green region would be the interior region, this entire green, and the two gray regions are the exterior regions. Corresponding angles. 1 and 5 are corresponding. 2 and 6 are corresponding. 7 and 3 are corresponding. 4 and 8 are corresponding. Alternate interior angles. 3 and 6 are alternate interior. 4 and 5 are alternate interior angles. Alternate exterior. 2 and 7 are alternate exterior. 8 and 1 are alternate exterior. Same side interior, 3 and 5, as well as 4 and 6. Now, because of our theorems about linear pairs vertical angles, we are able to prove quite a bit of congruence. You can see that when we do have these parallel lines with a transversal, there are only two angle measures that continue to repeat at both of these intersections. And I've color-coded all the congruent angles.